Today's video covers Lesson 16 in Module 3 for Level 7-8, proving the converse of the Pythagorean theorem. I'm going to walk through the alternate lesson questions and then have a few supplemental questions to go along in there as well. When we're looking at the Pythagorean theorem, just a reminder, that is when we talk about the sum of the squares of the legs of a right triangle being equal to the square of the hypotenuse. When we talk about a converse of a statement, if we look at questions 1 and 2, if you notice, this one says, if I am 13 years old, then I'm a teenager. On question 2, we have those flipped. Question 2 is the converse of question 1. You're essentially taking the question and you're flipping those phrases. So, if I am 13 years old, then I am a teenager. This is a true statement, because if you're 13, you are a teenager. There's nothing that can say otherwise on that. Number 2 says, if I am a teenager, then I am 13 years old. Well, that is false, because you could be a teenager, could be 13 to 19 years old, and therefore not just 13. So if you're a teenager, you could be any of these years, not just the 13 years old. If Mr. White is Sarah's teacher, then Sarah is Mr. White's student. Well, that is true, because if Sarah is in Mr. White's, if Mr. White is her teacher, then he is going to be her student. The converse of this says, write the converse of problem 3. The converse would just be changing the if and then parts. So if Sarah is Mr. White's student, then Mr. White is Sarah's teacher. And so if Sarah is Mr. White's student, then Mr. White is Sarah's teacher. This would represent a true scenario, because if Sarah is Mr. White's student, then he definitely is her teacher. There's nothing that's going to change what that says there with that. So after looking at some converses here, again, that's just saying kind of not the opposite of what's happening here, but just kind of flipping the statement. So the Pythagorean theorem says that if the triangle is a right triangle, then a squared plus b squared equals c squared. Well, what is the converse of the Pythagorean theorem? Again, that's just taking your if and then statement and then flipping it. So we would say, if a squared plus b squared equals c squared, then the triangle is a right triangle. What we're going to be looking at here in a minute is, if this is true, then we will be able to say that we have a right triangle. We're going to be kind of looking through here at this next verse. We're going to kind of do a little proof, and that kind of is helping prove the converse here. So, given that triangles has side lengths A, B, and C, where C is the length of the longest side, and a squared plus b squared equals c squared, then prove the triangle is a right triangle. So we're going to use these triangles to complete parts A through D. So in doing that, part A says to label the length of the hypotenuse x in triangle 2. So we have x. And then it says to write an equation to represent the relationship between the side lengths in triangle 2. Well, the side lengths are a squared and b squared. And the hypotenuse is x squared in this case. Because it is a right triangle, and we know that if we add these squares together, we get the square of this. Okay? So B says defend the claim that triangle 1 and triangle 2 have the same 3 side lengths. Well, we know that in triangle 1, okay, in triangle 1, we know that a squared plus b squared equals c squared. In triangle 2, we know that a squared plus b squared equals x squared. If you have two expressions that are equal to something, if something is equal to two different things, then those two things are equal to each other. So in this case, since a squared plus b squared is equal to both c squared and x squared, okay, we can say therefore, if I can spell correctly, that's why I teach math, therefore c squared will equal to x squared. Okay. We're just substituting in x squared for a squared plus b squared, okay, or c squared for that. Okay. However you want to say that, we're substituting in for a squared plus b squared to get this. Okay. And since c and x must be positive, because we're talking about measurements, c equals x. Okay. We're talking about measurements, so measurements must be positive. We can't have negative measurements even though we have a square. Okay. So we know that a and a are equivalent. We know b and b are equivalent because they're both a, they're both b. So we prove that c and x are equivalent because we know that a squared plus b squared equals c squared and a squared plus b squared equals x squared. Okay. So triangle 1 and triangle 2 are congruent. We have to defend this claim. Okay? Well, all 3 sides are the same in both triangles. So the triangles are congruent. Okay. The triangles have the same side measurements. So that makes the triangles the same. Okay. If all the measurements are the same in two shapes, that means that they're going to be the same shape. And finish the proof by explaining why triangle 1 must be a right triangle. Well, if the two triangles are congruent and triangle 2 is a right triangle, then triangle 1 must be a right triangle as well. Okay. If I know the two triangles are congruent, and I know that triangle 2 is a right triangle, that means that triangle 1 also is a right triangle. Okay. Triangle 2 is a right triangle. They're both the same triangle. Therefore, triangle 1 is also a right triangle. Number 7. It wants to find the unknown. So this is just practice with doing the Pythagorean theorem again. Okay, we have our a squared plus b squared equals c squared. If you notice, they give us the leg. Remember, the legs make up the right angle, but we tells us b. So we know that the hypotenuse has to be the bigger measure. So we have the square root of 35 squared, okay, which leaves the square root of 15 as the leg. Squares and square roots have an inverse relationship. They're inverses of each other. So when you have inverse operations at the same time, inverse operations will essentially cancel each other out. So the square root of 15 squared is 15. The square root of 35 squared, okay, squares and square roots cancel out, 35. Then we have to finish solving. We have to get the variable all by itself, isolate that variable by subtracting 15 from both sides. So we have b squared equals 20. Well, I still don't have the b all by itself. I need to unsquare, so to speak. I need to get rid of the square, so I have to unsquare. Well, what's the inverse of squaring a number? Taking the square root. Okay. So we take the square root of both sides, and the square root of b squared, squares and square roots cancel out. And since 20 is not a perfect square, we just simply leave it as the square root of 20. Just a little bit of review on the Pythagorean theorem. Okay. Next, we're going to look at the additional handout that we have that has some example problems on can we make a right triangle. Are the numbers we give a right triangle? Okay. And it even gives a little example here to see. Okay. It talks about here's a triangle with side lengths of 6, 16, and 20. So we're going to replace A, B, and C with these three. The longest side is the hypotenuse, so the longest side here is 20. For the shorter side, it doesn't matter. You could switch this around if you want. Okay, but we're going to replace A, B, and C with these numbers. We're going to square them, add this left side, and if you notice, we don't have an equal amount on both sides. Okay, this would tell me it's not a right triangle. Okay. We're going to look at question 1 first, and we have 9, 12, and 15. Okay. If you look at these, we know that 15 is the biggest, so it's going to have to be the hypotenuse. So I'm going to have a squared plus b squared equals c squared. There's our theorem. Okay. And then we're going to replace a and b with 9 and 12, and c with 15. Well, 81 plus 144 equals 225. Well, 81 plus 144 is 225. And we see that this is in fact true. So we do have a right triangle. Number 2. Again, we're going to do the same thing. We know that 6 is the hypotenuse. So we have 3 squared plus 5 squared equals 6 squared. 9 plus 25 equals 36. Well, 9 plus 25 is 34, which does not equal 36. So we do not have a right triangle. Okay. On question 7, next one I want to look at, if you notice, they're not in order of smallest to greatest, but the biggest one still has to be the hypotenuse. Okay, so we still have 81, we have 1600, and 41 squared is 1681. If you don't know some of these, it's okay to use a calculator to do the calculations there. When we add, we do get a true statement, okay, which says yes, there is a right triangle. What you're doing is you're taking those two small sides and plugging them in on for A and B. Then you're plugging the big side in for C, squaring all numbers, and adding the 2 on the left. If it's equal, it's a right triangle. If it's not equal, it's not a right triangle. Okay. I'd like you to do number 8 on your own. Okay, pause the video, and then we'll come back and we will see if you have the right answer. By plugging in the smaller sides and the bigger side, squaring them, adding them together, we notice that we do not have a right triangle because of the sides not being equal to the square of the hypotenuse.